All right, so far we have been working in Chapter 11, and what we've been doing now is using the AVO number. And we all know that as 6.02 times 10 to the 23rd of anything is equal to 1 mole. So we've been able to use this for both molecules as well as for atoms. And what we're doing now in the second section of Chapter 11 is we're changing over to moles and grams. And to do that, we have to use the periodic chart. Okay, so the periodic chart is what's going to be necessary for you to get the numbers that you need to make your fraction, the second fraction, in your calculation. So I did a side-by-side here to give you an idea of how this stuff is going to work. And let's see, where's my, here, get this down here, come on. Here we are, and we'll get this guy down here. Okay, there. So at the beginning, we wound up with this stuff over here. You'll see two-headed arrows. And the reason you see a two-headed arrow is because sometimes you'll be given the moles, sometimes you'll be given atoms and or molecules. This you already know. What the change is, instead of dealing with this number, we're dealing with this, the molar mass. Okay? And where do we get the molar mass from? Periodic chart. Everybody's pointing to the east, which is where the periodic chart is. Okay, that's good. So before, here's what was going on. We were given something like 2.6 moles. And let's go ahead and cover this stuff up so it doesn't get confusing. And let's also cover up this side so it's a little easier to look at what I'm trying to have you see. So if we were given 2.6 moles of atoms, we have to have moles of atoms in our second fraction on the bottom. And the AVO number is what goes on top. However, sometimes we don't have atoms. Okay? The atoms, if we had them, would be a large number, like this 6.02 times 10 to the 23rd. But we might be given moles. Where's the moles? Do I have the moles one? 2.6 moles of atoms. Okay. 2.6 moles of atoms. I think that's what I had to begin with. At any rate, if we had the 2.6 moles of atoms, this fraction is going to get us where we want to go, which is the moles. Now, if we had atoms, not moles of atoms, but atoms, then this fraction doesn't work anymore, does it? What do I have to do to it? Okay. Avogadro's number on top? It's on top already. On the bottom. Okay, I heard you wrong. I apologize. Okay, so yeah, we just have to flip that guy upside down, and then we're good to go. Okay? Now the atoms here will cancel with the atoms down there, and everything works right. So this is the same no matter what the atom is. There's no difference in the calculation. It could be zinc, it could be gold, it could be manganese, it could be vanadium, it could be chlorine, it could be lithium, anything. Okay? Now when we start working with the stuff over on the other side, it gets very, very different. Because now we have to look to the periodic chart. And so periodic chart is going to give us this number. We call that the molar mass. And it's just the mass of 1 mole of these atoms. So 27 grams of aluminum atoms is the mass that would give us 1 mole of aluminum atoms. And how much is 1 mole of aluminum atoms? How many? It's this guy up here, isn't it? right over here. Okay. 6.02 times 10 to the 23rd is 1 mole. So that's how many atoms we'd have if we had 26 grams. But we have 15. And so we're going to get less than a mole, aren't we? Now, if we switch this out and we say, here's the moles, see why these guys are similar? When we switch from moles to grams, then this side of the fraction has to be upside down from where it was before. And now everything works. Okay? So, hopefully what you've learned just now, and I hope you wrote it all down. If you haven't, look online and you'll be able to get it there. So now we see that what we were doing in 11.1 is different because there we were dealing with the AVO number, where now we're going to be dealing with the periodic chart. So let's go ahead and look at some examples. I'll give you 2 examples and then I'm going to have you work a couple problems on your own. So here's our first example. Given, find, please write these down, and then you're going to be really set to go when you get into your homework. All right, Linda, what has to be on the bottom of this fraction? Moles or grams? Okay. Okay, which is it? And why did you change your mind? Whatever's on the bottom of this fraction over here has to be canceled. The units have to be canceling this unit. So what's on the bottom? Moles. Okay. So if we have moles on the bottom, the number, this will stay the same as it was in the last section. That number of moles is always 1 in that second fraction. So it's 1 mole of carbon atoms. And what's a mole of carbon atoms going to be weighing? $12. Okay, so that's your number on top. Pretty easy, huh? It's really not tough at all. And you get your calculator out. In this case, it's a multiply problem. You get 15.0 grams of carbon at, whoops, ATMs. There we go. ATMS. There we go. So that's now correct. Any questions so far? All right, here we go with the second problem. I've got grams as the given. Okay, so with grams as the given, let's get Kendrick. Kendrick, what are we going to have on the bottom of this fraction? Okay, what are those gram numbers going to be? How many grams equals a mole of sodium? Sodium is number 11. Number 11. They're in numerical order. What? Yes. Okay, so what's going to be on the top of that fraction? 23 you just said is on the bottom. 1 what? Very good. Okay, there you go. And that's 1 mole of atoms. Now, ladies and gentlemen, I want you to understand something. When I shut up and ask him a question, and then I shut up again, he is forced to think. As he's thinking, that's when stuff connects. And now, when he gets to his homework, it won't be quite so difficult. So grams will cancel, and now we have a division problem, don't we? Okay, we're dividing the grams of sodium by grams of sodium, and we're going to wind up with moles because moles is on the top. And that's where we get to our 0.85. When you multiply 2 times 20 times 23, when you divide 23 into 20, you're going to get a number less than 1. On the calculator, when I do that, 20 divided by 23, the number that comes up on this calculator is long. Okay, I have 0.869565217, and I see students writing down all those numbers. That's not a good idea. How many sig figs do we have here? Huh? Melanie, can you tell me? Oh, yeah, she's not. I just marked her absent. Jeanette. 2. Good. Okay, because this guy's 2 and this guy is also 2. So, just like Tyler DeWitt showed us yesterday, okay, I have to go to 2 figures, and on my calculator it reads oh, this is 0.86. Did I put something in wrong before? No, I think I did it right. Okay, so I've got this number a little bit wrong. It's 0.87. But it reads 0.869 and then more numbers. So I just draw the number after the 6. I go next door and I look at that, and that's a number that's bigger than 5. So that's why this guy gets changed to a 7. Okay, any questions? Okay, I'd like you to do this on your own, and if you're watching this as a video, you've seen too much. So try working it on your own. Don't run your video backwards. Just try it this way without looking, okay? And see if you can get it right, and then we'll continue the video. So what we're doing now is we're asking a student about what that next fraction is going to look like, and the reply came back as 1 gram on the top. Well, this number comes from the periodic chart. So the 195 is what's on top, and the 1 mole is on the bottom, as you suggested. And then when you multiply these guys together, you're going to wind up with this. Now, Mary, I suggested to you that you use 4 sig figs for the platinum, where I use 3, okay? But 4 would be better because you have it. If you have as many sig figs as you have on the chart, if you have the same number of sig figs that they have in the given, go ahead and use it all. I didn't. What would be the number after 5? 0.1? 10, isn't it? Is it 0.0? Oh, okay.
Unless you're rounding.
Yeah. Okay. So what that would give us here is 4 sig figs, which means I'd need a decimal here, right? Putting the decimal there makes that trailing 0 count, whether it's to the left or to the right of the decimal. Okay? But we can't put another 0 in there because that would give it 5 sig figs. Yes? Don't round it further than you're given. In fact, to get your greatest accuracy, you'd go 1 more. Yeah, just do it as much as the given. That'll get you close enough that you'll be able to answer any multiple choice question. Okay, one more guided practice. Here you go. Give this one a shot. Okay, so here we go. We're looking at grams from titanium as being 47.867. I just went hog wild on that and gave it everything it had. However, so I went hog wild on this and put a lot of sig figs in there, but it still only gave us 2 sig figs in the end because this guy over here, he only has 2 sig figs. So in multiply and divide both, the smallest number of sig figs rules, and that would be the most accuracy that you could have in your answer. I hope this has helped.